Hi, this video is on finding real zeros of polynomial functions. So we have two things. We have something called the remainder theorem, and we also have the factor theorem. If you combine those two theorems together, you are going to know that the following three statements are equivalent. Some value of c, so then f of c is going to equal 0. X equals c will be 0 of f of x, and x minus c will be a factor of f of x. And we're going to use all these information to solve these problems. So let's take a look at this first problem. It says x plus 5 is a factor of this polynomial, and we want to find all real zeros. Okay, so the way we're going to work, we're going to use synthetic division. I hope you are familiar with how to do that. So we're going to use x equals -5, and we're going to set this up. So we're going to have -5, and here we're going to write our coefficients. So it's 1x cubed, 9x squared, 23x plus 15. And then we're going to proceed with this. We're going to drop the first number down. That's 1. -5 times 1 is -5. 9 plus -5 is 4. -5 times 4 is -20. 23 minus 20 is 3. -5 times 3 is -15, and it's going to be 0. It is expected that you're going to get 0 because they tell you it's a factor, so you must get the remainder of 0 here. Okay, it can't be any other way. Alright, so if you're not getting 0, there is a mistake. So we already know that one solution here, one zero of this function, is going to be x equals -5, and we already confirmed that. But what do we do now? So now you're going to do the following. This here is x cubed, x squared plus 4x plus 3, and we're going to set it equal to 0. So it's a quadratic equation that you should be able to solve. This one can be solved by factoring. We can factor it as x plus 3 times x plus 1 equals 0, and we can find that x equals -3 and x equals -1. Okay, so our solution set is going to consist of three numbers. It's going to be -5 that we had here, and also -3 and -1. In any order you want, you can write them. Okay, so moving on. Here's another example 2. So we have x minus 3 given to us as a factor of this polynomial. So that means x equals 3. Okay, that's what we're going to do for our synthetic division. So we're going to write 3. We're going to write our coefficients. 1x cubed minus x squared minus 14x plus 24. Okay, and we're going to perform synthetic division. Drop this number. 3 times 1 is 3. -1 plus 3 is 2. 3 times 2 is 6. -14 plus 6 is -8. 3 times -8 is -24. 0. Again, we're expecting to get 0 because we know it's a factor. And now we have to find the remaining, any remaining real zeros. So we're going to, this is 1x squared plus 2x minus 8 equals 0. So this one can also be factored. This one's going to be x plus 4 times x minus 2 equals 0, which gives us x equals -4 and x equals 2. And we have this solution here, don't forget that one. And we can write the solution set as 3, -4, and 2. Okay. So the next problem here, next example, we got 2x plus 1, and we know it's a factor of this polynomial. Please note this one's missing missing x, so we have to put 0 for x. And for this one, we know x is going to equal, we set it equal to 0, x is going to equal -1/2, right? So what we do is we're going to set this up, -1/2, and this is going to be 6x cubed, 7x squared, 0x, -1. Okay, so we are I'm going to go ahead and do synthetic division. 6, negative 1/2 times 6 is negative 3. That's going to give us 4. That's going to give us, multiply these two, it's going to give us negative 2. This is going to give us negative 2. Negative 1/2 times negative 2 is 1. And we have 0 as expected. So we got one number here. I want to remind you that if you ever have a situation when this leading coefficient is not 1, then these numbers must be divided by that number. So before you do anything, you're supposed to divide these numbers by 2. So this is 3x squared plus 2x minus 1 equals 0. We can also factor it. This can be factored as 3x minus 1 times x plus 1 equals 0. And that gives us two more solutions. One of them is going to be x equals 1/3, and the other one x equals negative 1. Okay? And we're going to write that, all of it. So don't forget the negative 1/2 from here, and then 1/3, and then negative 1. Okay? And I think we have one more example here. So we're trying to find real, all the remaining zeros of this polynomial. So we're given a polynomial here, but the challenge here is going to be, this is actually x to the 4th. So x to the 4th, and 1, 0 is going to be that number. So we are going to set it up. Since we're already given this number, we don't need to worry about anything. We already know what goes here. This is going to be 1x to the 4th minus 1x cubed, followed by minus 7x squared plus 1x plus 6. And what we are going to do here is we're going to drop 1. Hold on a second, let me get my red marker. I'm going to drop 1. And then we are going to go ahead and continue with this. So that's going to be negative 2 times 1 is negative 2. That's going to be negative 3. Negative 2 times negative 3 is 6. And then negative 7 plus 6 is negative 1. Negative 2 times negative 1 is 2. 1 times 1 plus 2 is 3. Negative 2 times 3 is negative 6. And we have 0. Okay. So what we're going to do here now is we're going to write, this is going to be a cubic polynomial. Okay. And we already know this is one number. So this is x cubed minus 3x squared minus x plus 3 equals 0. Okay, so we got a cubic one. Our problem is we don't know what else might be a solution here. We don't know how to solve. We don't really have a formula for solving cubic equations. However, what you can do here is you can solve it, you can factor it by grouping. So what we're going to do is we're going to have x cubed minus 3x squared together, and then minus, and then we're going to factor out negative 1. Be careful here. It's going to leave you with x minus 3. So we're just factoring this. The first set of parentheses you can factor out x squared, which is going to give you x minus 3. And here we factor out 1, which gives us x minus 3. So the factored form here is going to give us x minus 3 times x squared minus 1. We're going to set it equal to 0. So now in this form we can actually continue with this. So x minus 3 equals 0, or x squared minus 1 equals 0. This one gives us 3. This here we can do it by factoring. It's x minus 1 times x plus 1 equals 0, and that gives us 1 and negative 1. So even though we're only given one number and it's a 4th degree, we're still able to figure all these out. So our solutions are negative 2, we also got 3, and we also got 1, and we also got negative 1. And there you go. Okay. And one last problem we're going to do. So we have 1, 0 given to us, which is 2. And we have this polynomial. We're going to have to find the remaining zeros. So So let's find this. Let's go ahead and do synthetic division first. 1x cubed minus 7x squared plus 11x minus 2. Right? Synthetic division. Drop the first number. It's 1. 2 goes here, right? 2 times 1 is 2. That's negative 5. 2 times negative 5 is 10. I'm sorry, negative 10. 11 plus negative 10 is 1. 2 times 1 is 2, and 0, as expected. Right? So we know that this is true. We verified that. Not that we had to question it, but it's always good. So we have x squared minus 5x plus 1 equals 0. This one cannot be factored. So what we're going to need to do is we're going to go ahead and try to do maybe the quadratic formula. We're going to do x equals 5 plus or minus square root of negative 5 squared minus 4ac divided by 2a. And let's see what we get. So it is 5 plus or minus square root of 25 minus 4 divided by 2. So it is 5 plus or minus square root of 21 divided by 2. And these are real numbers. Square root of 21 is obviously positive number. It doesn't simplify. You can't really do it. It's not a perfect square, but it's a number. So we're going to get two numbers here plus 2 over here. And our solutions will be 2. They're going to be 5 plus square root of 21 over 2. And 5 minus square root of 21 over 2. And we are done with this problem. And I hope this was helpful.